Probability. Before we deal with probability, we need to understand and remember the basics of counting. Remember, in the previous section we did permutations and combinations. And also we need to keep in mind we're dealing with finite probability, meaning that the outcomes of the event can only take binary values. So either they happen or they don't happen. Consider an experiment where you have a sample space and events. So if the experiment consists of flipping a coin 10 times, then the sample space would be all the possible outcomes that I can get by flipping a coin 10 times. An event could be that all the 10 times I get tails. The definition of probability involves the concept of event. Remember that an event is a subset of the sample space. And here, this notation here, these little bars surrounding the set E and S, they mean the cardinality. And the cardinality means the number of elements in that set. So the probability of an event E happening is equal to the cardinality of that set E divided by the cardinality of the sample space. Consider this simple example. You have an urn that contains 4 blue and 5 red balls. The probability that if you pick one ball at random is that ball is blue is 4 divided by 9. So you have, because you have 4 blue balls, that's the event space, and then you have the sample space, which is all the different possible outcomes. So you have 9 balls in total. You have 4 out of 9. Often you need to compute the probability of combinations of events. So remember the complement of a set. Here we deal with something very similar. When we studied sets, we said that the complement of a set is equal to the universe minus that set. In this case, the complement of an event E is equal to the sample space minus that event E. And this is equal to 1 minus the probability of E. We have a second theorem here. This theorem will lead us directly into another topic that we'll talk about in a different section, and it's called the inclusion-exclusion principle. For now, let's take a look at this theorem, and during the synchronous session we'll prove this theorem. And for now, we'll say that the probability of the union of two events, E1 and E2, is equal to the probability of the sum of the two, the sum of the probability of each of those two, minus the probability of the intersection of the two events. We'll do some exercises during the synchronous session, and this should become much more clear.